Okay, here we are, section 10.1 notes, the law of sines. This is page 3. We're going to continue what we did with pages 1 and 2. You notice here this has been arranged alphabetically. So we've got sine alpha over A equals sine beta over B equals sine gamma over C. You guys keep in mind these are proportions. So depending on what you're solving for, it's perfectly okay to flip them over and use A over sine alpha equals B over sine beta equals C over sine gamma. Keep in mind, we've got our triangle over here to the right. We want to make sure that our capital B or our beta, whatever we're using, is opposite the side labeled B. So as we build this, we know we're putting the right pieces together. Realize as well, we are never going to set this up with all 3 parts. We're going to use 2 out of the 3 parts depending on what sides and what angles we have. So we can use law of sines to solve the triangle easily if we have angle, side, angle. That means we have the measurements of 2 angles and the included side. Just so we know what that looks like, that would be saying I have angle A, angle B, and I know the side between them. Okay, so angle, side, angle means we are talking about consecutive pieces or parts. When we talk about angle, side, angle, angle, side, we have got 2 angles here. We're going to go alpha and gamma and the side not between them. So in this case, we could have side C. We could have side A. As long as we've got a side that's not between those 2, we can still solve using the law of sines. Last one, side, side, angle. So that means I would have 2 sides and then an angle not between them. This takes a little more work because there's a possibility of some funky things happening, but we will look at that one at the end and take a look at all the possibilities. Okay, so let's move on here. Example 2. Use the law of sines to solve the triangle. Round the answer to the nearest hundredth. You guys, please pay attention to what it's asking for. If it doesn't get specific, then I'm not going to hold you to anything too stringent. Keep in mind here, we have got 1 decimal place in our angles and our side length. Your answer should have at least that. To be more precise, you want to go to 1 more place. So here we're asking for answers to the nearest hundredth. We want to round this to 2 places, which makes sense given what we have. And so here's the first thing I'm going to do. And you definitely don't need to do this. It just gives me the opportunity to make sure I'm not missing something. And so it doesn't really matter how I label my triangle. I'm going to label it this way, alpha, beta, gamma. I know that the side opposite alpha is side A. The side opposite angle beta is B, and the side opposite angle gamma is C. And I may have said side alpha earlier when I meant angle alpha. Sorry about that. And then I'm going to go ahead and throw in the values that they've given me. So I know that gamma is 102.3. Again, it does not matter if my picture matches the measurements. This is strictly so I can see what is across from what and see what relationships I have. Beta is 28.7. And then side B is 27.4. Keep in mind, this says feet. Your answers should be labeled correctly in terms of feet. Okay, so we're going to use the law of sines. I need a side and an angle across from it. Okay, so I can solve fairly quickly here for side C. And here's what I'm going to do. Because I'm looking to solve for side C, I'm going to put that in the numerator. I know that's got to be over the sine of gamma. And the other pair that I have to work with is B and sine beta. Okay, so C I'm trying to solve for. I know that gamma is 102.3. And side B is 27.4. over the sine of beta, which is 28.7. Now to solve for C, I'm going to multiply both sides by the sine of 102.3. And I'm writing this in there because as we go to use the calculator, there's something here that's going to be super important. In the past, we could get a little lazy about closing that back parenthesis on my sine. Here, if I'm going to divide by something after that, I've got to make sure that I am very specific in how I do this. So my calculator is going to look like 27.4. I don't know what that is. Times the sine, it's going to give me this front parenthesis, 102.3. I'm going to make sure that I close that before I hit divide. Sine, sorry, gives me that front parenthesis. This parenthesis is not so important. I definitely don't want to miss that though. And so we've got C equals 27.4. Again, you want to make sure that your calculator is set to degrees. And we get a length on side C that is 55.747. We want to round to the hundredths place, which means we want to go one place past so we can look. I guess these should be approximately equal since we're using those decimals. 55.75, and again, we need a label, feet. Okay, so I've solved for C. Here is what I'm going to ask. I don't need you to list alpha and beta and gamma and then A and B and C, but it is helpful if you are very intentional about marking off what you have solved for to make it a little easier for me to find it as I am looking through some of your work and grading. Okay, so we found C. I need angle alpha and side alpha, and you know what? I'm gonna start with the easiest piece. And typically I honestly do this at the very beginning just because it's kind of a no-brainer. We've been doing this since, what, 7th grade. The three angles in a triangle always add to 180. So if I have any two angles out of the three, it's really easy for me to find that missing angle. And so if I take my 180, I subtract the two angles that we have, the 102.3 degrees and the 28.7 degrees, I get that alpha is 49 degrees. So I have found two out of the three missing pieces. I need to find the length of side A. And so I'm going to use A over the sine of alpha equals, I could use C and sine gamma, but if there's any chance that I made a mistake on C and I'm plugging in a wrong number there, I'm going to make a mistake on A, and I don't want to do that. So I'm going to go back to B and sine beta because those ones were given to me, and hopefully I didn't write something down wrong. But use as much as possible that was given to you to start with. So I got what, 27.4 over the sine of 28.7. A equals 27.4 times the sine of 49. Again, I'm going to be very aware of the fact that I have to make sure I close that back parenthesis before I divide by the sine of 28.7. And I did not figure this out beforehand. It's not in my answer key. 27.4 times the sine of 49 divided by the sine of 28.7, and I get 43.061. 43.061. I'm going to write that in just so I make sure that I round correctly. And this is the length of a side. So it should have a label on it, a measurement. Occasionally you'll get a triangle that does not have measurements on those lengths. If there is a measurement, you need to make sure that you have included that. So we have solved the triangle. Angles gamma and beta were given to us in the problem statement. We found angle alpha. That's right here. Side B was given to us. We found side C and side A. And so that is it. We have solved that triangle.